You're a high school chemistry teacher, and you're teaching your students all about chemical quantities, including the mole. You want to convey your students all about copper sulfate pentahydrate. Not yet modeled like in this slide. You're instead starting with the crystals, as shown in this beautiful blue rock. Perhaps you're using the powder in this bottle, or you're starting with the actual crystals, and you're having your students grind those crystals to a powder after weighing, heating these up, and driving away all the water, so that your students can then use the mass difference to calculate the percent composition using the evaporating dish method. And with some teacher help, you can take them through these rather complex calculations involving gram to mole conversions, percent composition by mass, and finally, the determination of the empirical formula of this hydrate. I already made a video about that, how best to introduce the hydrate lab by focusing on the following question. Is there any water on the moon if you can only see solid rock? But in this video, I'm going to instead show you how I've now extended this lab activity with a modeling exercise that focuses on the next-gen science standards, namely HSPS 1-7, conservation of atoms in chemical reactions. I'm going to show you how I've modeled this with my students to underscore the law of conservation of matter. I printed out the following atom sheets, colorful, laminated them, had my students cut them out using the carbon, sulfur, oxygen, and hydrogen atoms, and also including the charges and parcel charges. Here you're seeing my two students using those exact atom cards and placing them according to the starting reactants. We now have copper sulfate pentahydrate. These are the reactants with a total mass of 249.5 grams per mole. Add a little bit of heat, and you can drive that water away. Those are your products with a mass of, for the anhydrate copper sulfate, 159.5 grams per mole, and 5 water molecules, a total of 90 grams per mole. Combined, the same mass before as after the reaction. The law of conservation of mass is the concept that is applied in this modeling activity. Now, I would be lying if I didn't coax them a little bit where those exact water molecules needed to be placed based on the actual crystal structure of the copper sulfate pentahydrate. Hence, the 4 water molecules around copper and the 1 water molecule around the sulfate polyatomic anion. But it is difficult for students to start this modeling activity without first modeling it as a teacher. So I start with an I do before I turn it over to them. So what you're seeing here is the cat and the polyatomic anion. But of course this reflects the anhydrate. In reality, we start off with the hydrate. Upon the addition of some heat, we can drive away those water molecules, now shown on the right of this slide. Further heating will actually drive all those water molecules away, turning the water into a vapor. So to emphasize the overall reaction, we're starting off with 249.5 grams per mole of the copper sulfate pentahydrate. We've turned that hydrate into 2 different products. The water component is 5 times 18 grams per mole, whereas the anhydrate component is 159.5 grams per mole, giving us the same total as what we started with, 249.5 grams per mole. The law of conservation of matter has thus been conserved. For the actual hydrate experiment, we started off with hydrate crystals. Take away the mass of the anhydrate, and hopefully your students don't have clumps, but actually nice, fine gray powder. Divided by the hydrate crystals, reflected here by the following mass amounts, and there's your percent composition of water by mass. If there's no error, 36% water by mass is what is calculated. If you are interested in all these lesson resources, this is what the Google Drive folder gives you. Percent composition of a hydrate and the teacher key, as well as the hydrate lab slides, the actual slides that enable you to print out in color the copper sulfate pentahydrate atom cards, and also the student lab demonstration, as well as the student atom modeling demonstration. If you want all these resources, go to the video description below, click on the link, and in exchange for your email, it'll take you to Astrid's science resources. The Hydrate Lab resources can be found under chemical quantities, because that is the emphasis of this concept. Thank you very much for watching. Bedankt voor het kijken. Tot ziens and see you in the next video.